So we're now going to turn our attention to something called the Flowable class, which is a very interesting class that was added later in RxJava. And we'll talk about what the Flowable class does, and we'll focus particularly with respect to its support for so-called back pressure, which is a mechanism that ensures that fast publishers don't generate events more quickly than potentially slower subscribers can process them. So the Rx observable class that we've been talking about up to this point does not support back pressure, at least not anymore. It supported it mildly for a while, and then they refactored the code, as we'll talk about here in a second. It can therefore emit a potentially endless stream of elements at very high rates, basically blasting them out as fast as they can be published. And therefore, fast publishers can quickly overwhelm the memory and/or processing resources of slower consumers. If you've ever watched the famous I Love Lucy episode with the, I guess it's chocolate or pies or something like that, it's a good example of what happens when you don't have back pressure. The pies are moving so quickly that, or chocolates or whatever they are, I guess it's the chocolate factory, they are moving so quickly that Lucy and her pal can't keep up with putting them in boxes. So they end up like stuffing them in their shirts and eating them and stuff like that. So that's the consequence of not being able to support back pressure, where things come too quickly to deal with them. To address this issue, RxJava 2.x, the second incarnation, a second epoch of the RxJava classes, introduced the Flowable class. And most of the operators in Flowable are the same as in the observable class, but it goes further and supports back pressure. It also supports something else we'll talk about later, having to do with parallel processing, but that'll come next. Back pressure aware subscribers can inform the publishers how much data or how many events that they can consume in one fell swoop, if you will. So for example, a subscriber could tell the publisher, I can get up to 3 events or 3 data on next calls, and then the publisher will publish those events. And then the subscriber can come back and say, OK, now I can get the next chunk of data. You give me 3 more events, and so on and so forth. So that way it can bound the amount of processing it has to deal with at any period of time. And the goal here, again, is to avoid overwhelming the memory and processing resources by ensuring that flow-controlled publishers, that's the key thing, flow-controlled or back pressure-aware publishers, don't generate events faster than they can be consumed by the subscribers. So that's basically the idea. I like to think of like a traffic light analogy, where you let a certain number of cars through, then you stop. And then you let another certain number of cars through, and then you stop. So there's this concept of sort of flow control. Non-back pressure aware subscribers can also apply a strategy that will be enforced if they can't keep up with faster publishers. And this strategy, as we'll see, has a bunch of different characteristics. You can buffer everything, you can drop things, you can generate an exception, you can only keep the latest version of something, and then you can also just let it do whatever it does without enforcing anything in particular, and just see where the pieces will fall together or not. So in other words, the non-back pressure aware model assumes that the publishers are not flow controlled. So there's 2 different types of publishers. There's flow controlled or back pressure aware publishers, and then there's non-back pressure aware or non-flow controlled publishers, and they can blast the data out as quickly as they want to, whereas the back pressure aware publishers can basically be used to regulate the data that goes out. Okay, so that's a quick overview of Flowable. Now let's spend a little time talking about the back pressure strategies. So these back pressure strategies are really intended for use by non-back pressure aware publishers and subscribers that basically say what to do if you get dated too quickly. And again, there are these 5 different constants that make up the strategy enumeration. And so buffers all the values until the downstream consumes it. That's desirable, except that you could run out of memory if there's lots and lots and lots of values. Drops the most recent value if the downstream can't keep up. Error will send a missing back pressure exception if the downstream can't keep up. In other words, if the subscriber can't keep up with the rate at which the publisher is generating the data. Latest is somewhat like drop, but it'll keep the latest value, overwriting any previous value. So when the subscriber gets the value, it'll be the latest value. And then missing will basically not buffer or drop. But again, you're sort of taking your life in your hands in that case, because you could run out of resources. These strategies can be provided using something called the Flowable Create Factory Method Operator. We'll talk more about Flowable Create here in just a second. But that's what can do this. And this will allow you to specify the back pressure mode or strategy that will be applied if the subscriber can't keep up with the publisher. So you can take a look at the EX1 project in my Reactive Flowable folder in my live lessons repository to see an example. We'll walk through this example later. This particular example will have a publisher that rapidly emits a stream of random integer objects in one fell swoop. So it'll just blast the stuff out. And then you can see here that the items that can't be processed will be dropped, which is the one strategy. We could have other strategies here. We could put buffer instead of drop or latest and so on. This operator, this create operator, is different from the observable create operator. We talked about observable create earlier. Observable create does not support back pressure, whereas flowable create does. And you can also have flowable operators, which we'll talk about briefly. And what you can do here is if you have the on back pressure drop method, then that goes ahead and tells the downstream to ignore all the items that can't be processed until there's room in the buffers to do them. So in this case, we're going to basically do something with mouse moves, but we're going to drop stuff if they come in too quickly. There's also an on back pressure buffer method, which you can basically tell it what to do, how long to buffer, and if it starts to overflow, what you should drop. Drop the oldest might be a good one to do. And then another example is on back pressure latest, which is like the drop strategy, but it keeps the last minute item. So this does not require you to use the flowable create operator, but instead you can basically interpose these helper methods, these helper operators to define the behavior of the stream. So that's the end of the overview of the Flowable class.